Drop an ice cube into a drink. It floats. This seemingly simple observation hides one of water's most profound and counterintuitive secrets. Almost every other substance on Earth becomes denser when it solidifies, causing its solid form to sink. Water is the bizarre exception, expanding by about 9% when it freezes. Imagine a world where ice sank. Lakes and oceans would freeze from the bottom up, making complex aquatic life impossible. This single anomaly is why we exist, yet it's just one of many ways water acts like a molecular rebel. Water covers 71% of our planet, but its commonplace presence hides profound mysteries, consistently breaking the rules of physics and chemistry. One of water's most incredible abilities is its remarkably high specific heat capacity. It takes an enormous amount of energy to change its temperature. This property acts like Earth's thermostat, moderating global climate with unparalleled efficiency. Oceans absorb vast quantities of solar radiation without drastic temperature swings, protecting coastal regions from extreme heat or cold. Water is often called the Universal Solvent, because it can dissolve more substances than any other liquid on Earth. From essential nutrients in our bodies to vast quantities of minerals in the Earth's crust, water's polarity allows it to break apart and carry countless compounds. This unparalleled dissolving power is critical for every biological process and geological cycle alike. Drop a tiny amount of water on a superhydrophobic surface, and it forms a perfect, near-spherical bead. This is thanks to water's incredible surface tension, a result of its molecules pulling tightly towards each other. It's powerful enough to allow insects like water striders to literally walk on water, defying gravity on a microscopic scale, or to create droplets that cling to spiderwebs like jewels after a morning dew. Beyond surface tension, water exhibits remarkable cohesion and adhesion. Its molecules stick tenaciously to each other, cohesion, and to other surfaces, adhesion. This dual property fuels capillary action, pulling water from tree roots hundreds of feet underground, all the way up to the highest leaves of California redwoods. Reaching over 380 feet against gravity, these magnificent plants wouldn't exist without water's unique stickiness. Most liquids contract steadily as they cool, becoming denser and sinking. Water, however, behaves strangely. It contracts until it reaches 4 degrees Celsius, then mysteriously expands again as it approaches freezing point at 0 degrees Celsius. This unique density peak at 4 degrees Celsius is fundamental. It means the coldest, least dense water stays at the surface of lakes, allowing aquatic life to survive winter beneath an insulating layer of ice. Scientists have observed water exhibiting an even more perplexing behavior, supercooling. Pure water can be cooled far below its freezing point of 0 degrees Celsius, down to an astonishing -42 degrees Celsius, and still remain a liquid. It needs a nucleation site, like an impurity or a sudden jolt, to finally crystallize into ice, instantly solidifying in a dramatic, almost explosive chain reaction. What if water isn't just one liquid? Recent, groundbreaking research, published in journals like Nature Communications, suggests that water might exist as two distinct liquids at extreme pressures and supercooled temperatures. One is low density, the other high density, rapidly fluctuating between states at the molecular level. This astonishing, two-liquid theory could explain many of water's bizarre anomalies, revealing a complexity far beyond simple H2O. Consider the cosmic implications. If water didn't possess these improbable properties, expanding upon freezing, its high specific heat, or its unique density peak, life as we know it would likely not exist anywhere in the universe. Our very existence hinges on a series of molecular mistakes that somehow conspire to create the perfect conditions for a habitable planet. It's a staggering stroke of cosmic luck that we call home. So next time you pour a glass of water, or see ice floating in a drink, remember you're witnessing a daily miracle. Earth's most common liquid isn't just common, it's a rebel, a paradox, and an alchemist, defying logic at every turn to sustain every breath, every leaf, every heartbeat on our planet. It truly is the impossible liquid, making the impossible possible. Which of water's impossible secrets blew your mind the most? Was it the floating ice, the supercooled liquid, or the incredible two-liquid theory? Share your thoughts and questions in the comments below. And if you are fascinated by these hidden truths, make sure to hit that subscribe button and notification bell for more mind-bending science every week. Your support helps us uncover more of the universe's greatest mysteries.